Hi, I'm Robert Coleman. I'm a Senior Applications Manager at Texas Instruments. Welcome to Power Tips. Welcome to Power Tip 21. In this Power Tip, we're going to talk about a mistake designers make quite often. That is, they put too much ripple current into a capacitor, cause it to overheat, and may shorten its lifetime. Okay, here's the ripple current in a capacitor as function of the duty factor. This might be the input capacitor in a buck power stage, and the peak-to-peak current in the capacitor is equal to the output current. So with zero duty factor, that is, with the high side switch on for a short amount of time, drawing current from the input capacitor, the RMS to output current ratio is very low, it's zero. And then it increases abruptly. By 20% duty factor, the ratio of the RMS to output current is already at 40%, and it stays above 40% all the way to 80% duty factor. Using this information, you can make a quick approximation of what the RMS current in the capacitor is just by taking 50% of the output current. Another very common mistake made by power supply designers is, for instance, in an input filter to a buck regulator, they'll put ceramic capacitors in there, and they'll put just enough so that they have sufficient rating for the ripple current in the ceramic. And then they get into a system and they realize that they need some damping in their system. And so they add an electrolytic capacitor, and they think that all the current's still in the ceramic capacitor. What they overlook sometimes is there can be significant current in the electrolytic also, and that may actually cause you to fail the rating of the capacitor. So just for instance, I took a buck power stage, put in sufficient ceramics, and then put an electrolytic capacitor in there, and I calculated how much RMS current was in the aluminum capacitor that was in parallel. In this particular case, at 50% duty factor, I had most of the ripple current in the capacitor. And in my particular case, there was not sufficient current rating for the capacitor to handle this much current. Well, thank you for your attention for this short power tip. You can find more power tips online by visiting Power Management Design Line and search for power tips, or you can click on the link to all articles in the description section of this video. Thank you.